Does that make them less important? No, it does not. Okay? You should be going through on the Canvas and looking in that textbook. There's also extra copies in here. If we have work time in here, we've got extra copies in here. There's a copy in the New and Improved Math Resource Center of the hardcover textbook. I can put more in there too. You should be going through these problems and saying, okay, I know how to do that one. I don't need to focus in on that one. Oh, wait a second. I don't know how to do this one. I better do some more just like that. Okay? And so on and so forth. So that you, by the time that September 19th rolls around, which is in not 1, but 2 short weeks, okay? In 2 weeks, that you're ready to go and that you start out strong this semester. Okay? Right? So just so you know, tomorrow you'll be getting a worksheet that will be collected, but the book assignments, those selected problems, will not. Good? Can I clear up some things on that one? On Thursday, I almost said Friday. On Thursday, the classes were all a pleasure with questions about the book assignments. All right. Today, we're going to solve stuff algebraically, paper and pencil way. Tomorrow, and nope, I lied. I immediately take back the tomorrow. Thursday and next week, Tuesday, we'll get you on the graphing calculators, and we'll start solving stuff graphing calculator-wise. Okay? So just so you know, today is going to be algebraic, and then later on this week, we'll get you on the calculators. We are looking at a formative assessment on Friday of this week because it's the 2-mod day. And I believe that it's 6 questions long. In fact, I know it's 6 questions long. Literally. So it's a 6-question formative on Friday. Any other questions to start today? Hope that everybody had a fun and relaxing, not super hot weekend. Really hot yesterday. I'll do some yard work. Okay. Let's do this. So, solving equations algebraically, quadratic equations. You have it written down there at the top of your P5. We're in the P5 section of the notes, just so you know. P5. AX squared plus BX plus C. That's the standard form. A, B, and C are real numbers. A is not equal to 0. Because if A was 0, then that would be gone, and now it's not a quadratic anymore. Now it's a linear. If A and B are both 0, now it's not a quadratic, now it's not a linear, it's called a constant function. Okay? So, just so you know, those are the different ones. Okay? This is called standard form. Positivity of A, B, and C, that is up for debate, that meaning it doesn't matter. But exponents, biggest on the right, smallest on the left. Or excuse me, other way around. I said that wrong. Biggest on the left, smallest on the right. Okay? In descending numerical order. Okay? Love it. So, we can solve quadratic equations. We can solve this because it's equal to 0. So we can solve that. There are many ways to solve it. Okay? So there's factoring. There's completing the square. You've learned all of those. Factoring you learned all the way back in Algebra 1. Completing the square you guys picked up last year. Quadratic formula. I think they touched on that in Algebra 1 also. Yeah. So that's 3 ways. We can also solve these using the graphing calculators. That's a 4th way. We'll get to that later on this week. Trying to think what else. Factoring, completing the square, graphing, quadratic formula. Yeah, pretty much it. Okay. Okay. Answers are either going to be real numbers, either real or either rational or irrational, or they can also be imaginary. Remember the eyes from last year? They can also be imaginary. We'll talk graphing Thursday. Love it. Here we go. Okay. Solve this by factoring. Okay. Now, you'll hear Mrs. Hill and I refer to it as the butt cheek method, okay? Because we're old school and that's what we used to call it. Okay? What we mean by that is we're going to take this part right here. We're going to look just at this part right here, and we are going to factor it into 2 parentheses. Okay? Two numbers that multiply, or two terms, I should say, that multiply together to be 4x squared. What are my choices? There are 2 of them. What 2 things multiply together to be 4x squared? 2x and 2x is one choice. What's my other choice? 4x and 1x, right? Okay, so my 2 choices. I like to go, when I'm factoring like this, I like to go with the middle one. 2x and 2x. Now, we may not be right, but we're going to check it to make sure. Okay? Then, I got to look at what numbers multiply together to be 3. I only got one choice there. What multiplies together to be 3? 3 and 1, that's all I got. Okay? Now the placement of the 3, the placement of the 1 is important. Not necessarily in this case because we chose 2x and we chose 2x. But if we would have chosen 1x and 4x, then that placement of the 1 and the 3 would be important. Okay? A couple of hints that you might not remember, but I'm going to remind you right now. This, if it's positive, if it's adding at the end there, then the signs inside your parentheses are going to be the same. If that is negative, your signs are going to be different. Okay, 1 positive, 1 negative. Again, order of that matters. Okay? To check this, to make sure we did this right, we look at our inners. Those 2 multiply together to be 6x. And we look at our outers. And those 2 multiply together to be 2x. Together, these 2 need to add up to be that. Okay? So as I have it, I've got 6x, I've got 2x. 6x plus 2x is 8x. So I have the right number, but because the 8 is negative, that means that both of these are going to be minus and minus. Then this becomes negative 6x, this becomes negative 2x, and now I get my negative x. Okay? So from there, then, now I've got it as 2x minus 3 and 2x minus 1 equals 0. Then we utilize something called the zero product property. And the zero product property says that if 2 or more things are multiplied together and the result is 0, 1 or both have to be 0. So what we do once we factor it is we set our factors equal to 0, and then we go through and we solve that from there. Add 3, divide by 2, and x here is 3 halves. Add 1. Divide by 2. X is 1 half. And together, both of those make it work. Okay. Questions, comments, concerns, clarifications? Oh, there it is. Zero product property. We just got done talking about that. I don't think there's an example down there. Whoop, whoop, whoop. Whoop. Okay, there isn't an example down there. I'm scared there for a minute. Okay. Another method is solving by completing the square. When you're solving by completing the square, the first thing that you need to do is you need to get all the variables on one side and the numbers on the other side. So you want to separate it out. Okay? So in order to do that first, I'm going to have to distribute in that 2. So then that's going to give me x squared minus 4x plus 11 equals 2x minus 10. Now, to get step number 1 complete, I'm going to subtract 2x from both sides. That brings all of my variables to the left side. At the same time, I'm also going to subtract 11 from both sides because that puts all of my numbers on the right side. That leaves me with x squared minus 4x equals negative 21. Now, you may be saying to yourself, why did Linz leave that big gap between the 4x and the equal sign? Okay. We're going to fill that gap by completing the square.
Is it 6x or 4?
Oops, that should be 6x. Yes, my fault. I just saw that one. I forgot to see that one. Is that better? Good catch. Yeah. So now the second step that you're going to do is you're going to ask yourself 3 really easy questions. The first question is going to be, what's your b? The second question that you're going to ask is going to be, what's your b divided by 2? And the third question that you're going to ask yourself is, what's your b divided by 2 squared? So in this equation, my b is the coefficient on the linear term. In this case, it is negative 6. Agree? Okay. What's negative 6 divided by 2? Negative 3. As I say, if we're struggling with that one, we gotta wake up. I know the heat's getting to me too. Okay? What's negative 3 squared? 9. Okay? So we've answered our 3 questions. Now in this gap that I put in right there, that's where that b over 2 quantity squared is going to fill in. So I put a plus 9 there. But what have I done to my equation? Is it still balanced? No, because I added 9 to that left side. So to make it be balanced again, I've got to add 9 to that right side. Now I'm back in alignment. Okay? Now, let me show you a shortcut. This left side trinomial is a perfect square trinomial, which means that when you factor it, when you do that butt cheek factoring, you're going to get the same thing in both of those sets of parentheses. That's what it means to be a perfect square one. But it will always factor, jumping today. But it will always factor to be that. Where this b over 2 number is now going to be in that gap right there. Always. That's why it's done that way. Okay. This then is equal to, what is that? Negative 12? Yes? Okay. So now we're there. Our next step is we are going to we're going to square root both sides. Okay. The square root of anything squared. Okay. So for instance, if I have the square root of 4 squared, what would that be? 4. The square root of 169, which is 13 squared, is 13. The square root of x squared, x. The square root of a triangle squared, triangle. Whatever we're squaring, we take the square root, that cancels out. So this left side, what does this left side cancel out to be? X minus 3, and that's it. Okay. Now we just got to work on the right side. So we've got here, off to the side, I'm going to go a little square root of negative 12. First off, memory serves me correct. Do we like the square root of a negative number? No, we don't. So that means we're going to automatically factor out a negative 1. Now I'm left with positive 12. Are there any perfect square factors that evenly go into positive 12? 4? 4 times what is 12? 3. So then this would be the square root of 4 and the square root of 3. The square root of negative 1 is I. The square root of 4 is 2. And the square root of 3 is the square root of 3. Right? Okay. Now, this is where you're going to get burned at some point in time on this next statement. When I'm solving and I take a square root, or an even root for that matter, there's one thing that I got to add in. plus or minus. I got to add in the plus or minus. So this over here becomes plus or minus 2I square roots of 3. Now, we're almost done because we want to get what x is equal to. So if I want to get what x is, why is it doing that to me today? It must be the heat. It's wilting in the heat, I say. I got to add 3 to both sides to get x by itself. So that in the end, I just have x equals, these two are not alike. They have to be exactly the same because there's extra radicals and i's and all that stuff. So this just becomes 3 plus or minus 2I square roots of 3. Don't be one of those crazy Algebra 2 students who then say, well, that's 5I times the square root of 3. Because they see that 2 and the 3 and they add them together. Or they subtract. Back in, just remember, if we need those brain pauses, we can take those brain pauses anytime we need it. Because sometimes there's a lot of stuff, especially here in Chapter P, when we're throwing all this stuff at you to try and get you to remember it. Hopefully some of it will stick, not just in the heat today, but hopefully some of it will stick in the brain. Like, oh yeah, I know how to do that stuff. Okay? So, the quadratic formula is this wonderful thing that's written on the sideboard right there. Just remember that from the standard form, it's the opposite of b, plus or minus, square root, b squared minus 4ac, all over 2a. You will not be given that formula in 2 weeks on the test. Okay? If you haven't memorized the quadratic formula yet, you're going to need to memorize. Very few things that we ask you to memorize here in pre-calc. But please get that memorized. Make your life a lot easier. Okay? In order to utilize the quadratic formula, you have to be in standard form, which means on this particular one, I'm going to need to subtract 5 first. Having it equal to 0 is the crucial part of standard form. And now then, 3 is my A, negative 6 is my B, negative 5 is my C. And it basically becomes a plug and a chug and a here we go. So it would be x equals, opposite of B would become positive 6 plus and minus negative 6 squared minus 4 times 3 times negative 5 all over 2 times 3. Doing some maths, we can do some maths in our head. Negative 6 quantity squared. 36. 4 times 3. 12 times negative 5. Negative 60. 36 minus negative 60. 96. So then this would become the square root of 96. 2 times 3? 6. Can the square root of 96 be simplified? Yeah? what are the two perfect, or what is the perfect square factor that goes into 96? 16, how many times? 6 times. Yep. So then this would become 6 plus and minus 4 square roots of 6 all over 6. We can only look at outside numbers now. So this 6, this 4, and this 6. Do those 3 numbers share a common factor? 2. Okay? Which means that they can all be then divided by 2. So we'd have 3 plus or minus 2 square roots of 6 all over 3. Ladies and gentlemen, please give a warm welcome to Mr. Schmeling. Lukewarm at best. What's this?
Better.
For tomorrow. Oh, for tomorrow. Yeah. Oh, yeah. I like it. I like how it's also in color, too. I like that. Those worksheets that you were talking about, they're on the bottom shelf of Cahill's cards.
Okay.
Just so you know.
She said they're for tomorrow.
They're for tomorrow.
Excellent.
Yes. So she'll bring them up with the whiteboards for tomorrow, too. Okay. Have a great day.
Hey, you too.
Good on that one? Love it. Okay. Lastly, we've got some, how do I want to say it? Absolute values, I want to say it. Hold on one second. Yeah. So an absolute value in its true mathematical definition is the distance a number, this might be in P7 now, is from 0 on a number line. Okay? So the distance that any number is from 0 on a number line. Distance is the key word there. All distances are positive. Okay? So that's why we basically say when we are finding the absolute value, we're just making it be positive. If it's positive already, we just keep it. If it's negative, we just drop the negative sign, and then we make it be positive. Okay? So that is why that is occurring, because of that distance word. Okay? I think we'll put it on that side. Put it on this. Okay? So what we're asking here in this first letter A, when we say the absolute value of x is equal to 5, we're looking for the two numbers that are 5 units away from 0 on the number line. Well, that would be 5 and negative 5. Okay. When we go into, and I'm going to take a quick peek ahead here, when we go into, that's an inequality, and I think, yep, okay, so we're only doing inequalities for right now. When we get into absolute value equalities, then we take whatever's inside the absolute value, and we set it equal to the right side. And then we take whatever's inside the absolute value, and we set it equal to the negative of the other side. Okay? So we can't really do that with an inequality. So we have to come up with a different way. So logic tells us that this right here is a distance, right? Because it's an absolute value. It's the distance that something is from 0 on the number line. And this is telling us that we want that distance to be bigger than 5. That's what logic is telling us. We want our absolute value, distance, to be bigger than 5. Well, I know that negative 5 and positive 5 are 5 units away from 0 on the number line. So anything in between there is not going to be bigger than 5. So I can put that, because it's not equals, and I want outside of that range to be my graph. That would be all of the numbers whose distance is bigger than 5 from 0. Okay. Now, we can do that in inequality. We could say x is less than negative 5, or we could say x is greater than positive 5, if we wrote it in our inequality form from last week, Thursday. Or we could write this in interval form. Oops. Whoa, tap the brakes, Lens. Not a bracket. Because it's not equals. Okay. Problem, graph, inequality, interval. Okay. Same problem, spun it around though. So now we're saying that the distance, right, needs to be less than or equal to 5. So again, I start out, 0's in the middle. If I go outside, my distance is bigger than 5. I want smaller than 5. So I'm going to flip them to filled in dots because it's the equality part. And we're going to make a nice like briefcase luggage backpack handle. In an inequality statement, it would be that. In an interval statement, it would be that. Okay? So here's one of those where now we've got some maths to do along with an absolute value, along with an inequality. And then at the end, we're going to put it in interval notation. Whew, that's a lot of stuff to do. Okay? All right? So the first thing that we're going to do is we're going to say we got to find those points on the number line that are going to satisfy this. So I'm going to say 2x minus 1 equals 5. and I'm going to say 2x minus 1 equals negative 5. Now, solve both of those. Go ahead, solve them. I got 3 and negative 2. Okay? So those are my key points on my number line. Okay? I want my distance, logic is telling me absolute value is a distance. I want my distance to be bigger than 5. Those 2 points have given me where the distance is going to be equal to 5. Or in this case, where my equation is going to give me a distance output of 5. Okay? So I want to be bigger than that. So I'm going to go open and open because it's a non-equal part. And because it's bigger, we want to be rowing the boat. Okay? It asked us for our answer in interval notation, however. So now we're going to take this and we're going to say, all right, this left side one started at negative infinity, came all the way up, but didn't include negative 2. Then we jumped over to 3, and we're going all the way out to infinity. Okay. Reminder that we have now in the textbook that's a PDF on Canvas, we've covered P1. We skipped over P2, but you should look at P2. We covered P3 and P4. We have covered the solving part of P5 and P7. We have yet to cover the graphing part of P5 and P7. And we have to do projectile motion from P7. We have 3 more topics to talk about in terms of graphing and solving graphing. Another alternative. Okay. That half sheet of paper that has the homework assignments on it, I believe it's also posted on Canvas, but you should definitely look through those pages on the PDF that is also posted on Canvas. Okay? Any questions for me? It's hot.